All right, so you can sort of see we're starting in the middle here because the previous recording I was making of this did not work because I've now closed like everything else to save this, and hopefully my computer will respond in like real time this time. Anyway, so the point is we're doing number 14 from the fall, from the exam given in fall 2023, which is the sample exam for fall 2024. And I'm just going to go from the top. Uh, so the order of omega is 24. And so we're trying to write out the elements of H2 and H3 and the sort of corresponding transversal between those two elements. And so, as you can see, we've already written that H2 is C4, which is generated by omega to the 6, because omega has order 24, and 24 divided by 4 is 6. And H3 is C12, which is generated by omega squared, because 24 divided by 12 is 2. And so if I write all these elements, uh, uh, it's sort of more, it's probably, let me start with it like by writing out omega, by writing out the elements of H2. This is still not super fast, uh, which are 1 omega to the 6th, omega to the 12th, omega to the 18th. Okay, great. Hey, at least this is slowing me down from when I'm talking, because I know I sort of by default I go incredibly fast. Uh, and then omega. So the elements of H3 are just all the powers of omega squared. So so that goes on to omega to the 22, and then omega to the 24 is 1 again. All right, so those are the elements of H2 and H3. And so now I'm going to do something that is not strictly required for the answer, but is sort of helpful. So in blue here, I'm going to explain, I hope remind you, but at the very least explain uh, where this answer comes from. Uh, so uh, so the point is, uh, uh, the way that we get the transversal between H2 and H3 is we start out writing out cosets of uh, of H2, negative the 12th, negative the 18th. Very good. Okay, okay, so that doesn't hit everything inside H3. So what we want to do is you take the first thing in H3 that is not already accounted for in a coset, and that's omega squared, and we take that times H2, which is omega squared. So remember, when you form a coset, you take everything in the original subgroup and just multiply it times that given coset representative. So this is everything times omega squared. So that gets 2, 8, 14, and 20. And omega to the 4th. So omega to the 4th is the first thing that's in H3 that's not already accounted for in some coset. And so we get omega to the 4th, uh, omega to the 10th, omega to the 16th, omega to the 22nd. And lo and behold, if you sort of go up and down here, 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Everything's accounted for. Everything in H3 is accounted for. And so this now represents H3 written as a union of disjoint cosets of H2. And so the transversal T23 is going to be just exactly those representatives in the front, 1 omega squared omega 4. So any questions so far? You can ask them out if you just say no questions in the chat if you have no questions, or ask a question in the chat if you have a question. All right, great. So no questions so far. So let's go on to part B. In part B, write out the elements of the subgroup fill stage of step 3. That is, for all the elements corresponding to the elements of H3, write out the formula for y of t in terms of the inputs x. Okay, so now let's see. So we're gonna need 12 lines here. Uh, who wrote this thing? That's a lot of stuff to write. Oh well. Anyway, we're gonna need 12 lines. So here we go. So this is gonna be y of 0, y of 2, y of 4, y of 6. What jerk wrote such a long problem on a final exam? Uh, y of 8, y of 10, y of 12, y of 14, y of 16, y of 18, y of 20, and y of 22. Okay, so now, so let's see. So the spiel is that is that the beginning of this thing is always the beginning of each one of these equations is going to be an element of the is going to correspond to an element of the old subgroup. So yeah, so you can see these 0, 2, 4, 6 correspond. So these 0, 2, 4, 6, and so on over here correspond to the exponents in the new subgroup, 0, 2, 4 up to 22. And then the x values are just going to start off. So you can't just read this off the formula. Just for reference, here we have, even though I'm not going to really use this directly, we have m equals the sort of old uh, uh, generator is m equals 6 and k equals 2. So you can just read this. You can just actually read this off the formula if you like. But I'm not actually going to do that. So the idea is that the thing to keep in mind is that uh, output number J uh, comes from a sum that starts with input entry number J. So yeah. So if you look up here at if you look up here at the there we go. There we go. Um, so if you look up here at the input subgroup 1, 6, 12, 18, that means these things are going to start off these sums are going to start off 0, 6, 12, and 18. So but then actually as you sort of cycle around here, uh, each of these things will start off 0. So even though the y's keep increasing 6, 8, 10, 12, 14, the x's will cycle back around and you'll get 0, 6, 12, 18, and then x of 0, 6, 12, 18. Yeah, so and because D note that because D uh yeah, because D equals 3, this will cycle around exactly 3 times. Yeah, because right, because m sort of increases three times as fast as k does. All right, uh, that's how you get the starting points of each of those individual equations. So questions about starting points. All right, I'll take that as okay. Great, no questions. All right, so then and then the subsequent indices all uh, come from offsetting the starting points 0, 6, 12, 18 by the indices corresponding to the powers of the transversal, so 2 and 4. So we x of 0 plus x of 2. And I'm going to leave a space for the twiddle factors, and then x of 4. Uh, and then offset x of 8, x of 10, x of 14, x of 16, x of 20, x of 22. If I were smart, uh, I would have just like done this part and then sort of saved it and then copied it for the next part, but I'll just sort of keep going. Um, anyway, uh, so as I sort of fill in the rest of this, can you put in the chat, can you put in if you have any questions about where these 2, 4, 8, 10, 14, 16, 20, 22 things are coming from? Yeah, so I know not you can just sort of fast forward this part of the if you're watching on video, just hit fast forward. Um, okay. Or like skip ahead 10 seconds or something. But I've committed to this and I'm going to do it. Uh, X of 16 and X of 20 and x of 22. And I've left off the the space for the twiddle factors in the first in this first column because that first column remember well for any number of reasons, but that first for one reason is the first column corresponds to r equals 0. Right, that first column in the first entry in each sum corresponds to r equals 0, and the twiddle factor is always going to be 1. So so you really need to start the twiddle factors with the second column and the third column. All right. So what are the twiddle factors? The twiddle factors are always going to be. Let me put this in blue. The twiddle factors will always be omega the transversal elements. So that's 1 omega squared omega to the fourth. Yeah. So the second column is going to be omega squared, and the third column is going to be omega to the fourth, raised to the minus jth power. And so remember, because uh, this first thing is actually j equals 0, second thing is j equals 1, third equation is j equals 2, fourth equation is j equals 3. Uh, the first column will have, again, the sort of first row will also have no twiddle factors. So the twiddle factors really start with the second row. So it's omega squared, omega to the minus 2, omega to the minus 4. Yeah, so it's twiddle factor. It's the transversal element raised to the minus j. And so they just keep sort of going up in power. So minus 4, omega to the minus 8, omega to the minus 6, omega to the minus 12. Haven't cycled around quite yet. Omega to the minus 8, omega to the minus 16, omega to the minus 10, omega to the minus 20. All right, great, great. We're halfway, and we have minus 8 to the minus 12. And now we have omega to the minus 24. And omega to the minus 24, remember, is 1. And so there's actually no twiddle factor here for this element. And then just to keep going, omega to the minus 14, omega to the minus 4, back to the omega to the minus 4 again, and so on. So I hope you sort of see how this pattern works uh, and how everything works out in a reduced fashion. So, uh, uh, and I'm sure you can also note, if you practice this enough, you'll see all kinds of other patterns showing up here, all of which are really there. That's right. So, any questions before 22? Oops, minus 22 to make that clear. Omega to the minus 20, and there we have it. So, and I'll pull back and let me zoom out so you can see the whole thing. There's one whole answer to part B. So any questions before we move on to part C, which is the sort of the new part. So from JM, so Tina, you had a question about from JM. Okay, well, there's a question in the chat that just says from JM. So I think I know what that means, and so let me just note that these entries over here in that first in the first entry in every equation is from JM, right? So that 0, 6, 12, 18, 0, 6, 12, 18, that is literally JM, right? So because when you have uh, so when you have uh, so when you have r equals 0, the first thing that's going to show up so the first thing that shows up in every equation, which corresponds to r equals 0, is just x of jm. And so they all start at that's right, they all start at x of jm. Uh, Right. And so and the question, and another question, we don't have to fill in the Y1, Y3 elements. No, no, yeah. So the subgroup fill part corresponds only to the omega, the elements in in H3, right? So yeah, so that is correct. For subgroup fill, you're only filling out the parts that correspond to the subgroup H3, and so that's 2, 4 up through 0, 2, 4 up through 22. So good so far? Okay. Great. So let me zoom back out and finish C and D. And I think, uh, for which I think I might have to just generate another page here. Do we have enough? No, there's probably just enough space to do. Uh, okay, to do this subgroup subdiagram. All right, so for the subgroup subdiagram, uh, okay, so I need to have 12 boxes here. Oops, that was not quite wide enough. Uh, Let me be optimistic and think I can fit 12 boxes in here. All right, so that's 6 boxes apiece. Yeah, this will work. One, two. Okay, so these are the outputs. So the output subgroup corresponds to 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. And here's the input. Uh, oops. Okay, so 12 boxes on the input. Now remember the old subgroup was 0, 6, uh, 12, 18. And but remember the inputs at this step are going to come not just from the outputs for this step are going to come not just from the inputs coming from the old subgroup, but also sort of those things offset by uh, the off oops offset by the uh, the transversal, and so the inputs x of 2 and x of 4 all come into play. All right. So now, that being said, if you're like completely not a visual person, you're like, oh my God, what is it? What is this diagram thing all about? All the diagrams thing is saying is that zero comes from the output zero comes from the inputs 0, 2, and 4. And so, uh, yeah, so zero comes from 0, 2, and 4. Oh, we have like zillions of colors here, so this will be good. So that first sort of bit of circuit says the inputs 0, 2, and 4 go to the output 0. So are there any questions? Let me actually, I'll just do two of these, and uh, and sort of correspondingly, uh, go back to blue here. So the the input the inputs 0. Oh, that was disappointing. Okay, oh, there we go. The inputs 6, 8, and 10 are going into output number 2. Okay, let me do one more, just because well, okay, let me stop there for the moment. So, any questions? Uh, so, uh, so, any questions about those two pieces for the first two pieces of the circuit, the subgroup, subdiagram? So, if you're just not a visual person, if you're like, I just like the formula, just write the formula correctly, and all this picture is a picture of literally of the formula, without the twiddle factors, but it does sort of capture the complexity at least, and so it is useful for if you are a visual person like I am, this is pretty useful for thinking, oh, I can actually now see what what the complexity what the complexity is that's going on here. Okay, I'll take that as a no questions, and so I'll keep drawing piece of the diagram because I have all these because I am on this little cute little system here. I do have all these. Um, yes, the first column is input. Oh, that's a good question. Which are the inputs and which are the outputs? Well, that's what the arrows represent, right? But yeah, the left-hand column is the inputs for step 3, and the right-hand column is meant to be the outputs for step 3. So yeah, first column is input, second column is output. That's the reason for the arrows. So it makes sense? Okay. So all right, let's see. Let's hope this maybe this green will work out. Will show up well. Yeah, that's green shows up great. So the next three inputs go to the next output, and then the final three inputs 18, 20, 24. Sorry, 18, 20, 22. My bad. Which I'll put in orange. Uh, it's too close. Let me try light purpley pink here. There we go. Those go to number 6. Um, okay, so and the rest, and then the rest of this sort of follows suit. Uh, let's see. So going back to red, uh, the first three inputs, the first three inputs go to 8. Uh, the next three inputs are what goes to 10. Uh, the next three inputs are what goes to 12. And the last three inputs, and the last three inputs go to the output 14. Okay. So and now for the last four outputs, 0, 2, 4 goes to 16, 2, 4, 6, 8, 10 goes to 18, or it will once I get this drawn. 12, 14, 16 goes to 20. And 18, 20, 22 those outputs, the inputs go to output 22. All right, and so there's the subgroup subdiagram. It looks pretty definitely clearer here uh, because of the way because of the colors. With a little more planning, you can also make this come out in black and white just fine. But I hope you can I hope it's like relatively clear because of the colors. And now if I now pull back and compare uh, uh, the diagram and the equations. So, for example, uh, y of 16. Yeah. So here's to pick a random example. Y of 16 is x of 0 plus x of 2 times some stuff plus x of 4 times some stuff, and lo and behold, yes, 16 does come from uh, these guys over here, 0, 2, and 4. And that's all this diagram is. It's just sort of showing uh, which inputs contribute to which outputs. So questions on the diagram. Again, I'll take that as a no. And so just to finish up the chat over here, just to finish up, uh, right? So the y is the output, and it's sum of the uh, x inputs. That's correct. Yes, the point of those x and y the point of those x and y equations is that the y's are the outputs and the x's are the inputs, and that subgroup that subgroup fill stage tells you how the outputs are derived from the given inputs. Yeah, I know. I've sort of uh, reversed, yeah, because of the sort of clashing conventions of how you write a computer program. Yeah, sorry. I know that the equations have the inputs on the left on the right and the outputs on the left, and the diagram has the inputs on the left and the outputs on the right. Um, Sorry about that. But you know the equations. That makes sense. I see your objection here. So the equations are written using the convention of computer programming, where the sort of things you know already are on the right hand side, and the things are setting are on the left hand side. So if you write a computer program, that's like literally what you have to write. Uh, on the other hand, because in English we generally read from left to right, this diagram shows the passage of time as going this way uh, because, well, because that's the way we generally show the passage of time. And the arrows sort of show that things are going left to right. So, yeah. So sorry that those two conventions clash slightly, but I hope it makes sense now if it didn't before. That's a good question. Yes, especially yeah, sorry, especially sorry if you happen to have grown up in reading a language that goes in a different direction, that might be mighty confusing. But okay, hope that makes sense now. All right, so one last thing, which is the complexity. So now, now we're going to talk about complexity. Uh, for complexity, you remember, so part D. Oh yeah, so just for for clarity, that was the answer to part C. Now for part D was asking about the number of exponentiations, uh, and the number of multiplications, and the number of additions. And this again is not uh, uh, ends up being not that deep once you get the idea. Here, D is 3, right? Meaning and you can see that 3 in a number of different places. D is 3 because D is 3 because of this equation here, but D is 3 because there are 3 elements in your transversal. D is 3, and therefore there are 3 summands in each one of these individual equations. Anyway, so D is 3, and capital N is 24, as mentioned in several times. And so for exponentiation, so the number of exponentiations is always going to be D, right? Because there's 3 sort of even though you can sort of cheat and sort of say like, well, you don't ever have. I guess if you're clever, you would never actually if you were efficient, you would never actually write your loop to have any twiddle factors in the first, and that'd probably save a little bit of time. Be slightly faster is worth doing. But for the purposes of complexity theory, that well, you might as well just include those because there's really a twiddle factor there. Just always turns out to be omega to the 0. So there's 3 exponentiations and 3 multiplications, as you can see, like right above this. There's up here. There's right above this. You can see 3 multiplications in every and two additions because it takes 2 sums to add 3 things together. So that's the number of things happening in every equation. And remember the number of equations is always capital N, right? Because in every step of the FFT, you have to set capital N outputs. And it's probably reasonable to remember that the number in each step there's 3n exponentiations, 3n, dn exponentiations, dn multiplications, and d minus 1 times capital N additions. So there's the new stuff, parts C and D. All right. And I think we have finished. So any questions? Okay, great. So I'm going to stop the recording. See you, internet. I hope that was helpful. Bye.